people are actually finding that the happiness scores of customers are higher now with some kind of language model than when they were talking to a human. Because the language model can just keep optimizing, working out the best words to say at the right time to make the majority of people happy or something like that.
Hello, everybody. Welcome to the Humans of Digital, our podcast at CI&T. This is another episode where we're going to talk a lot about generative AI. My name is Rodrigo. I've been working with generative AI for the past year and something, and I'm really happy and excited with everything that's going on. And we have a few people here with me to talk. So, Mika.
Hello, Rodrigo. So my name is Mikaeri. I'm working as AI machine leader at CI&T. Also working with AI since 2018, and it's very happy to be here with Sam, another GD that I met through the Google Developer Experts, and even before watching some videos from his channel. I'm so glad for you to be here, Sam, with us. Tell us about yourself.
Sure. Hi, everyone. My name's Sam. I'm a co-founder and CEO of a company called Red Dragon AI. We do a lot of stuff around language models specifically and conversational systems and stuff like that. I guess in relation to Gen AI, I was doing Gen AI when sort of the first GANs came out, and we called that Gen AI back in like 2016, 2017. And I have a GitHub repo to prove it, right? That actually says generative models on the repo, which I occasionally show to people as a joke. I guess I've been working on language models since sort of 2017, 2018. We've had papers on language models at workshops at NRIPS in 2018, EMNLP 2019. It's been something that we've been very interested in, the whole idea of language models and language modeling in particular, and then also the idea of sort of being able to fine tune these models to do specific things. So some of our papers were specifically around that, of like, how do you actually then fine tune these things to be able to do few shot learning or to do different tasks that you want to try and do with them.
Very cool. I now feel that I need to learn a lot more because both of you folks have been dealing with AI for much longer than I. But Sam, you not only has this transition, but you also very committed to like helping kind of demystify the idea of AI. Is that something that you're kind of passionate about? I don't know if I call it that. I know that you have your YouTube channel, you have other sources and other places that you post a lot and all of that. How do you feel about generative AI to, I'm going to call general masses, but not necessarily everybody, right?
Yeah, I guess in some ways, like the YouTube channel was a whole accident, right? People ask me a lot about, oh, you've got a big YouTube channel or something like that. That was never the intention. The intention was to put up some videos for my friends to see how to code some things or how to do some things like that. And then it seemed to be, it was almost about a year ago now when I did that, when I sort of kicked it off. And that seemed to be the perfect timing for when LLMs kind of took off. So it was a little bit after ChatGPT. People were starting to get aware of these things, and things changed very quickly. Like, that was something. Yeah, I definitely do think, I do like the idea of demystifying a lot of this stuff. I think that a lot of the big companies don't really want to tell people how this works or how to do things like that. It's not in their interest to do that. But a lot of these things are, ideas that have been around for quite a while. And yes, people are developing them, people are getting better at them, people are trying new things out. But a lot of the fundamentals really haven't changed that much, in a long time. It's just that we've got much bigger models, much more data, much more compute. And suddenly now these things look, really amazing and almost intelligent, or, and I always say that they have understanding with inverted commas. So for those of you who are listening, I'm sort of doing air quotes of inverted commas of understanding, because really at the end of the day, they don't understand things. They just give the illusion of understanding. But then maybe some humans do that also.
That's a very good point. And it's you talk a lot about models in your channel, and in here you brought up a bunch of different ways, but when you think, and I think since you like to demystify and you touch a little bit on the big companies and all of that, although I agree with you to a point, but I also think that these big companies like OpenAI, Meta, and all of that, they were able to do something very cool, which is put AI in the hands of folks like my mom. I think that's part also of the magic, because I agree with you. Like Transformer is just an architecture of things that were already there. So it's a different way of using techniques that were already there. But they were able to do something very cool, which is put in the hands of non-tech folks in a way to interact with AI. So in a kind of way, they kind of demystify it too. Do you have any comparison between that and how the more, I don't know, open source models and all of that are doing things?
I think, like, look, I totally agree with what you're saying in regards to ChatGPT. Like, I can remember when ChatGPT came out, you know, I guess for those of us who've been working in it, it wasn't a huge advance. Like, it was like, oh yeah, this is good language model. It's very nice. Wow, it seems to be instruction fine-tuned. It's getting the instructions really nicely and stuff like that. I guess what we didn't see at the time was exactly what you said, that like your mom would start chatting to this thing and she would chat to it, my guess is in a way that the people working on these things had never chatted to these things, right? It was much more like a real human, like, you know, treating it like a human or treating it, you know, in these ways. And that really did change, you know, that's been the sort of thing that kicked it off. So Google, you know, had models like this, you know, with the Lambda models, the Mina model and stuff like that, but they just wouldn't make them public. You know, they really did, you know, were really scared of the reputational risk. They didn't want to, you know, do a lot of those sorts of things. So it took someone like, you know, ChatGPT come along with OpenAI and really change everything. And of course that's a good thing, right? You know, I totally think that. You mentioned like Meta. Yes, definitely, you know, Meta sort of being pushed into open sourcing these models where first, you know, someone torrented the weights for the Llama 1 model, and then they realized, oh, actually, you know, having all these weights out there, they can actually get cool stuff out of it, meaning that they could see how people were fine-tuning it. They could see, you know, how people were quantizing it to put it on phones and all this sort of stuff that probably they themselves didn't think about. And then they sort of realized, okay, well, we should double down on this with Llama 2, and then in perhaps, you know, later this year, Llama 3, right? So yeah, it's, I agree with exactly what you said, that, you know, having people who don't know anything about this stuff suddenly get involved in it, in many ways is an awesome thing, because suddenly people were just like, you know, holy crap, this can work, and this can do things that, like, you know, they wouldn't believe that they were actually just talking to an algorithm. They you know, tend to anthropomorphize it and basically project that it's a real human, and, oh, where is this person that I'm talking to? Where are you hiding them in the room? Or, you know, that kind of thing. And there are a lot of funny things, I think, like that comes out of that. You know, yeah, it's funny because, like, for researchers, I think a lot of researchers thought, yes, ChatGPT is really impressive, but it's, you know, it was kind of expected, right, that these things, you know, were going to be like that, because it'd been getting better every year, and quite consistently better every year. But you're totally right that like having people that just didn't know anything about this suddenly think, oh, you know, and I guess the scary thing with that is that a lot of people then start to think, oh, we've already got AGI, we've already got, you know, this evil sort of AI that could take over the world and stuff like that. That's the sort of the scary part, where, you know, I guess a lot of those people don't realize how hard it is even just to get these things to add numbers, right? Or, you know, something like that, right?
And so I don't know if you have the same perception as me, but for example, it was so hard for you to advocate in favor of AI to be implemented in an organization. I mean, for 5 years ago, but now you have to sometimes ask for the companies to be like calmer in that, because they want in a rush to be able to add AI in their pipeline. So and you have a lot of things to consider in that, right? You have, for example, these models, they are large, they require infrastructure. Sometimes if you have to put an open source model in your pipelines as well, and also the guardrails. We have a bunch of things to care about. So I see that now we are in different shapes, and comparing to 2023, when you see 2024, now that the companies already saw the power of AI, and that is something that will be part of our daily routines. Now we are gonna be seeing what's the value that it really generates for me. Okay, now that I see that it can be added in any part of my pipelines, what is the best part that I can add that I will have the best return as well? So this is very interesting, because now we can talk about multimodality in a way that we can add videos, audio, not just language. That was the thing from 2023 in my point of view, right? So I don't know what you see about it, but about the state of these large language models, and not just language, right? So let's unbias this conversation to be able to talk about video, about audio, that I know that you already talked to me about Lava. So what is your point of view about that? Are you using that? Are you being able to implement in real clients these models, and how do you see it?
So I have to be a little bit careful about talking about clients, but yeah, like the look, you're totally right that this year is the year of multimodality, right? A lot of us were hoping that last year was going to be there, and it was kind of there a little bit in that, like GPT-4 had the vision thing early on, but they just didn't have the GPUs to be able to serve it, to be able to get it out, that kind of thing. Gemini, was, I guess, always intended to be a multimodal model. So that's, that's sort of taking off. Really, just we're I guess we're recording this on the last day of February. It's only in, I'm just trying to think. I think it's 2 weeks tonight, right? That 2 weeks or 2 weeks today that Gemini 1.5 was announced.
Yes.
Right. So it's literally like, we're talking about something that that's only 2 weeks old, which seems crazy, right? Yeah, and like I was lucky to get early access to that and play with it and make some videos of it and stuff like that. And one of the things there was, it just blew my mind. Yeah, when I could take like a whole video and just throw it into it and start getting it to answer questions about things, or I could put in like multiple books in there and get it to answer questions and stuff like that. That was sort of like huge. I think we've just scratched the surface. So I think in the not too distant future, I think it's okay to say this, Google's planning on putting the audio version in there as well, so that you will be able to have text, video, images, audio as inputs, which and if you look at the sort of research papers for Gemini, the audio, it's understanding is better than sort of Whisper, right? So it can sort of transcribe things better than Whisper, and so when you've got that combined with the images or the video of whatever it's watching, then being able to process those words as kind of like language, that's pretty powerful, right? And one of the cool things that people didn't really talk about the Gemini paper is that for a long time, people have wondered, like, okay, if you've got multimodalities and you're learning from images, you're learning from audio, you're learning from text, is that kind of like 1 + 1 + 1 = 3? Or is it 1 + 1 + 1 = 4 or 3.5 or whatever it is, right? And their paper really showed that it does actually enhance things, so that when you've got the multimodality of knowing, knowing the audio, knowing the video, you've now probably got a better world model inside this model. And having that better quality world model means it can understand things better, and it can then basically, respond better to whatever it is that we're trying to get it to do. So I think that's where multimodality is going to become huge. We've seen a lot of interest from some of our clients who do stuff where they need to make maybe object detection models or something like that. And suddenly now some of these VLMs can answer questions about images and and do that, which in a different way than the sort of like the object detection model can do.
Is it like
a lot of
Sam, like VQA, visual question answering, more like that you were using, right? So you can use these models, right?
Yes, yes. So the small models, like the small Lava and stuff like that, are not great. Of course, they're nowhere near as good as like Gemini 1.5. But it's kind of amazing what they can do. Like even there's a really cool model that I didn't make a video about, which I should have, called Moon Dream. And I've been waiting for them to basically bring out a version 2. So if I understand correctly, the version 1 is you can't use it for commercial things because of the training data, but they're working on making sort of new training data to train up a version 2, which you could use. So this basically uses like the Phi model from Microsoft as sort of the LM. And then they've got like a vision model, a vision transformer on top of that. And this thing is small and super quick. Yet when you play around with it and you ask it things, it's amazing, what it can do. It's also really funny sometimes what they can't do. Like I was really kind of curious of like, okay, what could you try these things out? To sort of see like, okay, and you'll ask it like a question about, hey, what's in this image? And it will appear to be like super intelligent because it'll tell you, something like that. All right, one of the common things that people are always worried about, that they want models for is detecting not safe for work pictures or something like that, right? These models were awful at it. Right? So I tried it out with a picture of a girl that had, that was topless. And I asked it like, okay, what do you notice about this picture? Hoping that it would go, this is topless. This is not safe for work. Don't use this. And it came back and said, oh, she's got a really nice necklace on. which I thought was kind of hilarious that it noticed, and it was true. And I went looking. Yes, she had a necklace on, but that was probably not what we wanted, the model to actually notice. But again, because it's never been trained for that kind of thing, it just didn't, pay attention to that. It could get things in the background. It could work out, all these sorts of things. But this is where you've got to be careful with these small models. Is like, okay, what are they actually trained for? What can you actually use them for in production? That kind of thing.
I love this example. Maybe the model is less biased than we are. So
I don't know, but it really didn't know. Like it was quite comical that like if I showed that picture to any human, straight away they would go, she's topless, or she's naked or something like that, right? That would be the first thing the human would notice, but a model would notice everything but that, which I thought is kind of funny. That it just shows that like it's never been trained for it, right? It's never sort of and I guess this is the interesting sort of thing is that as these models make it into production, really a lot of the time we're going to need to fine tune them for very specific uses. So if you want it to detect planes, if you want it to detect, something really cars or something, or people in an image, probably people in an image, it can kind of do that. It can kind of work out that because it's seen things like that. But maybe for like, detecting something really specific, that's going to require fine tuning. Which is fine, right? We all know that, like, that, okay, this model's a tiny model. If we can put together a data set, we can fine tune it. We can then probably get it to do different tasks that we want. It's funny because in research and in the big companies, people are trying to make models that can do everything, right? Like one model that can do everything. In production, you actually end up getting small models that can do one or two things really good. And you don't really care about it not knowing, a lot of like, 90% of the things, because you're just using it for a very specific use case. And this is where, fine tuning is so important, is that if you can fine tune it for your specific use case, and it does that really well, you don't really care about, other things. Whereas obviously Google has got real issues of where they have to sort of train up a model that can handle any kind of query that someone's going to throw at it. For most of us, what we're doing in, when we're building things that are going to go in production and stuff like that, a lot of the time, not always, like, yes, okay, sometimes you're going to have a chat bot that will talk about different things, but a lot of the time, you want a model that's really good at one thing. and it doesn't really matter that it's not good at something else, right? That's kind of irrelevant to the to what you're sort of going for in there. I think that's something that a lot of people don't realize. You know, like I even see this a lot with the open source community, is that they're trying to play the same game as Google, as OpenAI, which is awesome. Don't get me wrong, right? And I'm not talking about people like Meta and stuff like that. I'm talking about like, you know, some of the people doing Finetune, some of the things like that. They're trying to basically make a model that could compete with GPT-4 or Gemini or something like that. And yes, they're getting closer and closer all the time, right? That's awesome that they're doing that. A lot of the time, though, if you've got a language model and you've got it doing customer support, you don't want it to talk about philosophy of life, right? Yep. The last thing you want is a customer going, oh, tell me about the meaning of life or something like that. For things like that, you just want it to say, oh, you know, I'm sorry, I can't really talk about that, you know, now, but let me help you with your, you know, your ticket or your problem with the product, or, you know, that kind of thing. So that's a very different kind of use case than what we sort of see with things like ChatGPT and you know, those kind of things.
Yeah, and of course, it's about fine tuning. I do want to follow up on that, but you touched the point, which is production workloads and all of that. We've definitely been seeing on our side, at least conversations that I'm having with the past couple months, with it seems that the models, it doesn't matter if it is a large language, like a real large language model like Gemini, or smaller models, but it seems that they made it easier to have productions workload related to AI, because a couple years ago, you actually needed to build your model from scratch. Like the idea of fine-tuning a open source model, or that was already really powerful, was not something that existed. So it was really hard to, the success rate of AI projects was really low, just because it's so hard it was to convey the objective or get the information out there. And we seem to be shifting into much more AI-powered applications and software, just because now we can leverage these models, specifically open source, being fine-tuned. Or even to your point, I see a lot of companies now trying to just get the full-blown Gemini or GPT and putting it to solve customer support. It might not be the best approach long run, but at least it's an open door, right? How do I start with all this? Because that's the challenging part for production workloads. How do you actually make it concrete so people can see the value? So have you been seeing a shift also? Because I know that you actually specifically talk about AI with a bunch of your customers. Is that something that you agree with that sentence? Because for our clients, it's been like that.
Yeah, look, I think this kind of goes back to what Mika said earlier on as well, was that you're totally, you know, both of you kind of made the point around that, that suddenly AI has become acceptable, right? 5 years ago, it wasn't acceptable, right? People would be like, oh, so we're going to, you know, take this stochastic model and it's going to make a prediction and it's going to be wrong some of the time, right? And customers or clients would basically be like, oh, no, we want 100% accuracy. We can't have anything better than 100% accuracy. A good example of that was back in 2018, we worked on a system for scanning ID cards in a particular country that Google didn't have an OCR system that was very good for that and things like that. And so, you know, I was thinking, okay, we got to beat 100%. And it turns out that this particular company that wanted this product, they had 100 people sitting there taking, you know, people would take their mobile phone of their ID card, take a picture, send that in, and then one of these 100 people would type it in. And the accuracy for the humans was like 85% on a good day, right? On a good day, it was like 85%. So, you know, suddenly it really meant that, like, oh, you know, you realize, oh, actually humans are not 100% accurate, right? People think that, oh, humans are infallible, they're always going to get it wrong. That's not true at all. We're sort of seeing with, you know, going back to the customer support thing, that a lot of customer support things are where people are actually finding that the sort of the happiness scores of customers are higher now with some kind of language model than when they were talking to a human. Because the language model can just keep optimizing, working out the best words to say at the right time, make the majority of people happy or something like that. You're right that like it's become a lot easier. You could fine tune models in the past. So Google released open source. It's funny because a lot of people are seeing sort of Gemma that just came out of Google and thinking, oh wow, Google's finally open sourced a model. Actually, Google's open sourced models for a long time, right? With the T5 models, with the Flan T5s. There's a whole bunch of models that they kind of open sourced as well. The challenge was that most of those models were just not trained on enough data so that when you fine-tune them, you could get them to do what you wanted, right? It would take a lot of data to, being able to get these things. But yeah, look, with what both of you said, I think is key, is that now we're seeing this attitude change that AI is acceptable, and people are then open to like, okay, well, let's try an open source model, or let's try a proprietary model from OpenAI or Mistral or Google or something like that. It's definitely interesting where it's going. So I just did a video this week for Mistral. So Mistral's just launched a new large language model. And one of the things that's really interesting about that to me is that they've kind of said in their blog post, look, if you want to run this on-prem, if you want to basically, put this, like if you've got some use case where you can't go and ping an API because your data has to stay, on site or something like that, contact us and we'll put some, we'll look at, if it's worth it, we'll put something together. Okay, up until now, OpenAI and Google have refused to do that, right? They don't want to put these models on-prem for people because they're so worried about it. The fact that Mistral's kind of like got a really good high quality model, and they're saying now like that, okay, we're prepared to put these things out on-prem for people to, to use, as long as my guess is they're going to charge for it. Obviously, they're going to charge a good fee for it. But that's going to open up a lot of applications too, right? That, like you mentioned before, a lot of people are sort of going for these big models because they're, they can do so many things or something like that. But that meant having to upload your data to Google or upload your data to OpenAI or to Azure or to whoever it is. So I think, slowly that's going to change too.
Yeah, and that's an interesting part of the conversation, like making the model your own to your own application, which basically has two paths ahead, right? You can go the fine-tuning way, or you can go RAG with all the elements inside of that. I know that we have been having some success with RAG, and I'll let Mika speak a little bit about it in a few seconds. Also, how do you been seeing, Mika, what on our side, what we've been seeing between those two, and how do we leverage RAG, as you can see, that in this way of making the models our own models, right? In the sense of how do I bring my data to there?
I believe that the discussion between fine-tuning and RAG is very interesting because people tend to have to choose between one or the other, right? And I don't see it that way. I feel that we can mix the things. I'm seeing, guys, Sam is agreeing with me here. We are talking right now. I can see Sam. But what I believe, Rodrigo, is that we are having a lot of success with RAG. But RAG is changing. It's not like the naive RAG we used to have before, when we simply get the text, we split that text into chunks, and with those chunks, we do the embeddings, storing a vector DB, so on and so forth. So I saw a paper, it's called like Retrieval Augmented Generation, a survey, where they explore 3 types of RAG. And the first one is the naive. We explored that in the past, but we also have some techniques that we can do in the end before even retrieving to the client. For example, the re-ranking stuff, using cross-encoders and other techniques that can help us to have better chunks in a better position. So you also have that. We also have other things that we can do to avoid the loss in the middle problem, that is when your context, the meaningful one, is in the middle of the text that you're gonna add before giving that to the model. So there is some research that tells us that if you have something that's very important for the model to answer, when this sentence is in the beginning or in the end of the text, you are gonna have more success and more better accuracy before retrieving that to the customer. And this is very important because with that techniques, you can avoid your not your model, but your final result to have less accuracy than we were expecting. So with that, you have to balance, right? You have to always see the research and try to implement, see what makes sense for your specific task, because not all the things that we see, they're gonna perform good for your use case, right? So that's what I'm seeing. But I also see a lot of things regarding the different types of search, for example, indexing versus doing your search in the whole document. So not having to maybe break down into chunks. So I don't know, that's what I'm seeing right now, not using RAG as it is, but it's being very good for us to use RAG, not just fine tuning, you know, Rodrigo, but for sure, I believe Sam has a different experiences on that topic. And I don't know if he has been exploring different search mechanisms as well.
I think, like, I totally agree with what you said. That, like, I don't see it as an either or, right? I think in a really good system, you're probably going to end up doing some fine tuning. If it's an open source model, you're going to do some fine tuning to give it, to give the model the tone that you want it to have to respond in. Right. So if it's doing customer service or something like that, you want a certain tone. That's one thing. You also want to get it to be used to the kind of language that your RAG system is going to use. So if you're doing RAG over research papers, that's very different than if you're doing RAG over, you know, marketing material or, you know, you know, product manuals or something like that. That's very, you know, very different kind of thing. So I think, like, the fine tuning side, yes, there's always going to be a, you know, a point for that. I think with the RAG, one of the biggest things that people don't realize is that there is no perfect system. So really, you have to be able to try things out, benchmark that, try other things out, benchmark that, and then start to get a sense of, like, okay, this is probably the way to go for our system. One of the things I think we're going to see a lot more of, we're already starting to see this, is multi-retriever RAG. So where you're not just using one retrieval method to get the data, but maybe you're getting the data from, like, a vector store, and then also from a SQL search database or an Elastic search database as well. You're, you know, maybe getting it from a knowledge graph or some, you know, all these sorts of things. And then you're doing some kind of re-ranking, or then you're doing, you know, some kind of, like, you're getting lots of things and you're kind of trying to re-rank down to exactly what is most useful for this query. I don't think RAGs, you know, I see a lot of people saying, oh, wow, with, like, you know, 1 million tokens in the new Gemini model, oh, we don't need RAG anymore, right? That's not true at all. And because for a start, it's, you know, it's slow, right, to run 1 million tokens through that model. Now, of course, it's going to get faster, yes. So, you know, people are going to say, oh, well, that's just now, you know, in the future, it's going to be. The thing that I think that a lot of people are missing, though, is that for a start, 1 million tokens is a lot, but it's nothing to a bank, right? You know, a bank could have, like, you know, easily billions of tokens of content in their, you know, systems and stuff like that. So it's great that it can do 1 million tokens. It's great that it can do 10 million tokens, but even at that point, you know, it's not going to, you're still going to need some kind of RAG at some point in there. The other thing that I think we're seeing a lot of people starting to understand, which is something that I think we kind of used as a trick early last year, was the whole idea of query rewriting. So that when the person says something, just doing a naive search or a vector search or a similarity search on that is often not going to get the best material. So you kind of want to take that query and then rewrite it in some way. And maybe you rewrite that, you know, to be a sort of keyword query that you then use for an Elastic search or, you know, BM25 search or something like that. You use it. Maybe use something like hide, where you basically write the answer. You get a language model to write the answer, a fake answer, to the query, and then you do your search against the fake answer. can get really good results. There are lots of these sort of little tricks that people have sort of realized. And the thing is that they don't always work. Sometimes they work, sometimes they don't. It was really interesting on the OpenAI Dev Day that they had a sort of more in-depth talk where they talked about like things that they had done for RAG. And they showed 2 customer examples. And one of them, they showed that like, oh, with this customer, we used HIDE, right? So if for those people who don't know, HIDE is hypothetical document embeddings. And basically the idea is that if you think about it, if I want to ask about something on the menu of McDonald's, right? What are the things on a McDonald's menu? Most people, I guess, around the world know a McDonald's menu, right? Like you've got burger, you've got some kind of burger, Big Mac, fries, these sorts of things, right? But that's probably not going to be in my question. If I say, if I say, hey, Rodrigo, what's the best thing to eat at McDonald's in Brazil, right? Or something like that. Now, if you think about that query is probably very heavy on Brazil and not super heavy on McDonald's, and certainly not heavy on the types of food that McDonald's in Brazil would sell or something like that. Whereas if we've got the Brazil part and we write a fake answer to that basically says, oh, Big Mac, French fries, and Brazil, now we go and do a vector search on that or a similarity search on that, we're probably going to get actually much more useful things out of the vector store than just doing the search on McDonald's and Brazil if we're and we're asking about food kind of thing. So that's something that like OpenAI showed that worked really well for one of their customers, and then the next customer it just didn't work at all, right? So the frustrating thing there is that there isn't a sort of a guaranteed way of that, oh, you just do this and this and this, and then you get a perfect RAG system, right? I see that people asking me a lot of that on YouTube and at events when I give talks or something like that. People go, oh, well, okay, so tell me, what's the secret? What's the best RAG, right? And there is no secret. It's right. It's like you try a lot of these things out. I guess the secret is in how to do some of the benchmarking in some ways, like the actual testing and learning to look for the different things like that. That's something that I kind of feel that a lot of people don't put any effort into, and therefore they end up getting sort of subpar results. The crazy thing is, like, even naive RAG for lots of problems will get you to like 80%, right? Maybe even 90%. In there. And so people will be like, oh my God, this is awesome, right? Look at it. We ask it this, it gives us the right answer. We ask it this, it gives the right answer. And it's only later on that you realize, oh, hang on, if we ask it this, it gives us a totally wrong answer, right? And so you then start to work out that, oh, okay, it's good for maybe 80% of what we're doing. So then you've got to start thinking about, okay, well, how would we handle the other 20%? Or what else could we do so that it gets 93% rather than 80% for these things. And I think that a lot of that's got to do with benchmarking systems. A lot of it's got to do with trying different ideas out and just sort of seeing what works. There's a lot of these things sort of become like hill climbing, in that you're trying to get to that really high accuracy rate or something, and you try something out and then you realize, okay, we got that there. Now we'll try something else there. Oh, that gets us a little bit more. Try something else. Oh, that didn't work. Okay, so now we go a different path and try. This kind of idea is, I guess in many ways, perhaps you could say that data scientists don't like this idea because they're used to just being able to say, no, what's the algorithm that will just give me the perfect solution? And that's not turning out how it works, right? That's with these things, that just doesn't seem to work like that. I find for every different RAG thing that I've built, it always has a different kind of sense to it. Like, there are some really cool things of where you do multiple searches, you do re-rankings. That definitely seems to work a lot. That's a useful thing. But it's not like you can just say to someone, oh, okay, here's the magic recipe, and it will just work for every RAG. It just doesn't happen.
Yeah, I think you nailed it in the head when you mentioned naive RAG solves like a good portion there, depending on use cases, but it can go up to 80, 90% of
Yeah,
your problem.
yeah.
So the first time that you actually interact with the RAG application, even with the naive approach, really great results. And you just said, yeah, we're ready, let's do this. And then you start digging deep and it doesn't work. And also, I think on this journey, people are starting to realize there's more to RAG than just a vector database. And that goes to on how do I structure search and all of that. But also, I see lots more people talking about, hey, is our data actually something that we can throw in as part of the RAG, or should we rework part of this data? Because there is information out there that, depending on how you structure, it'll actually worsen your results. Like I was having a really good conversation with a friend about examples in a text. So they had an example from, hey, this is how you calculate your water usage, for instance. And it was really good information on what was the actual information, how do you get that? But then there was one example. And they said, when we indexed everything, unfortunately, there was a chunk where we indexed just the math count. And by the end, it said something like, hey, and then you spend 50 gallons of water. Perfect. If you ask, how much do I spend on water? The model will always respond, 50 gallons of water. No, that's the example. That's the, so there's a moment where people are starting to realize now, okay, there's a little bit more to how do I give data to these models and how do I search things, which is very interesting right now to be discussing these problems, because now it's about those 10% on top that are yielding. But the funny part is great result, catastrophic result. There's not like, hey, it's getting worse. It's like it really works, or it just crashes.
And the frustrating thing can be sometimes too that you then look into what the vector store got, and it's really obvious when, okay, the vector, you realize, oh, the vector store didn't get anything useful, right? So it's like, okay, well, now I understand why it's wrong. But then sometimes you look at it and it got useful things, but the language model didn't pick up on that, right? Or it wasn't sort of phrased in a way, and that kind of thing. It's something that's really interesting. But like exactly what you said, right, is that if you go in and you look at your data, often you will suddenly just go, I get why it's saying 50 gallons, right? Because it says 50 gallons in this chunk here. And so like, the whole thing of, we've seen a lot of, if you think of RAG, we've kind of got like, the retriever part, and then we've got everything to the right, which is the language model and stuff like that, all that sort of stuff. But then on the left side, we've got all the ingestion stuff. Right? Like, how do we get the documents in? How do we do splitting? How do we do, some of these sorts of things? And I think that's the area that this year we're going to see a lot of people talk about more. That's something that I know a lot of, that people are sort of working on solutions so that they can get better ingestion of data, so that therefore the raw data is just much more useful to get answers out of. And I think that's something that we'll probably see a lot more, going forward. And I think that's where the multi-retriever thing comes in too, is that now people are starting to realize, well, maybe we should have like one vector store, but maybe we should also have like a keyword search or an elastic search, or have something that's different, that's not just the relying on this sort of similarity score. Because similarity things work really well for certain things, but they don't work well for other things. And exactly like what you said, like the 50 gallons, that's really similar to how many gallons do I spend? Oh, 50 gallons, that's kind of similar, right? Okay, so I just say that as the answer, right? But you can see that's a perfect example of where you don't want that, right? You kind of want it, to basically, and maybe that's where query rewriting is really good, so that you could basically sort of rewrite the query to focus not on the gallons, but to focus on a formula or to focus on some kind of other thing. I definitely, realized at certain points that the rewriting of data is also really an amazing thing. It can be very expensive, but like, just getting chunks rewritten and stuff like that to be in a format where you can sort of say to a language model, here's a chunk of text, what would be you know, 3 to 5 questions that someone would ask that where the answer would be in this text, right? And that kind of thing can lead to really interesting kind of then deciding, oh, okay, well, we could rewrite the answers like that. You know, that's something that would be you know, difference. And then you've also got things like, you know, different size chunks, you know, different size splitting, you know, all that kind of thing as well.
And it's very interesting what you mentioned, particularly this part of the chunking, because when we start talking about RAG, we believe that there is a formula for you to choose the size of the chunking, and this size that you just discovered will be applied for any document type that you ingest. And it's not like that, right? Because, for example, for PDFs and for you to ingest repositories is a brand different thing. And when you go in PDF, it's not even the same for any PDF that you place for all the PDFs. So, for example, depending on the type of the document, depending on the domain that you are ingesting, things are going to change. And sometimes indexing is not going to be the final answer for you. Sometimes you have to explore, like, maybe knowledge graphs will be able for me to retrieve the information that I need, right? I believe that the key is for you to structure your data for us to be able to explore different ways to search it. Because if you think from the beginning, how can I structure this for example, for me to be able to perform a search like naive way or the advanced way, or even to be able to have like a knowledge graph search here. So for example, we could maybe, depending on that, implement like the graph rag that I don't know if you saw, but Microsoft released an article talking about it, because sometimes if you ask something for chunks, it's not going to be able to retrieve that, even if you performed a very good ingestion part, right? So it's very interesting for us to test and see what performs better. I believe that the key is also that, like, structure our data and also be able to have fail fast and learn faster, because with that, you're going to be able to see what makes sense or not with your project and your domain, right? So unfortunately, we are heading towards the end. So I'm already very happy with our conversation here, with what we discussed. Sam, you have a huge experience in the topic, so it was very nice to understand other points of view, what you have been doing, what you have been exploring, your thoughts on the subject, and very interesting for me to learn with you always. So it was a pleasure meeting you in Singapore, and right now talking to you about such a topic that's very impactful for us in all the things that we're doing right now. So would you like to say something to the audience about their journey, for those who are starting, for those who are tackling a specific issue, and would like to know from you like a tip for them to overcome it?
First of all, thank you for having me. Right, it's we've now met up in San Francisco, Uzbekistan, and Singapore. Right, so next time's going to be Brazil. Right, that's what I'm cheering for for that one.
Well, I hope so.
To give people tips and stuff like that, and the thing I would say is just try stuff out. You know, the biggest thing with language models is there are so many things about language models that no one knows a definitive answer, all right? Because this is such new technology, and when you talk to like some of the researchers at these big companies and stuff like that, you'll be surprised that you find sometimes that, you know, they were trying to work out, oh, could we prompt a model to do this? And they thought, oh, no, we can't do it. So then they just have a competition in the office where it's like, okay, anyone and everyone, and not just like the people who know the model. Because the thing that, you know, that I was trying to convey before when Rodrigo talked about his mom playing with, you know, ChatGPT and stuff, actually, often it's people like that that can get things out of these models better than us who work with the models every day, because they just don't think about it in the same way. I have a good friend who, when he talks to ChatGPT, he encourages it. He says, "Hey, ChatGPT, how you doing today? I'm doing really good. We're going to have a really good session today." And the crazy thing is, I look at some of the transcripts and I think, why would you do that? That's just like silly, right? But I can't deny that the responses he gets back are more friendly and are more sort of geared to what he wants, which I think is just astounding, right? That that kind of thing does work. It's sort of, and there've now been a lot of papers and stuff like that that show these things, and but my point being that, like, experiment, right? If you're not sure what works, read around what people are doing, but then experiment for yourself and see for your use case, does it work for what you want to do? Does it work, at being able to produce a certain result or get something that you want out of it? The experimentation thing is by far the thing that I think, we've seen so many people that didn't have ML backgrounds and so many people that didn't have sort of any AI background come into the sort of industry over the past year and do really well just because they didn't know what they shouldn't do. Right? Meaning that, like, they just thought, okay, well, what if I try this? What if I tried fine tuning like this? What if I did it like, this? And that's awesome, right? I think that's fantastic for those of us who have been practitioners for a while, that we can constantly learn from people that are new to the field because they're just trying something out. And I think that's one of the dangers is always, for those of us who have worked in the field for quite a while, is we constantly need to be thinking, okay, if I just throw away everything I know and I started again fresh today, how would I try and do it today? Or, how would I think about it differently? And I think that's a key thing for learning how to do stuff. And where, I'm kind of lucky that I hear, things from a lot of people, or, talk to different clients and stuff like that. And you realize that every use case is slightly different. So don't get boxed into thinking that, oh, okay, there's just one way to do this, right? You maybe have some nice notebooks or some nice code that you can go, okay, well, let's try this out and see how this goes. All right, we've now got a baseline, right? Now with this, how can we improve this baseline? And I think that, one of the cool things, like I mentioned earlier on, that the OpenAI Dev Day showed that that's exactly what OpenAI is doing, right? So it's not like they've got some secret formula and they've got it all worked out and they're just not telling us. No, they're also experimenting and trying things out. So that's the tip that I would say to people, is just try stuff out, see what works, learn from it, try new stuff.
I like that approach. I'm going to take that advice myself. Try new things. Sam, it was a real pleasure having you here with us. Love talking with you.
Awesome.
Really good conversations, really fun conversations. I like your point of views quite a lot. So thank you so much. Thank you so much for everybody that was here with us today also. If you like to hear a little bit more about GenAI and all of that, we do have a few other podcasts already out, and keep track because we're going to launch a few others talking about good stuff. Also, please, if you can follow Sun's channel, we'll make sure that we'll link some way close by so you can see there's a lot of good content out there for you to start learning new things and experimenting with it. So with that, thank you everybody for being here with us.
Thank you for having me, guys. It's a lot of fun.
Thank you. See you next podcast.